So this one, a local candy company has had great success with its new neon candy bars. The neon candy bars are featured in a range of 5 bright colors. They were designed to entice children with their visual appeal and have been selling extremely well. Recently, the company has been flooded with complaints that children are experiencing extreme hyperactivity shortly after consuming the neon candy bars. The company's original candy bars have not generated similar complaints. So the new ones are making kids climb off the walls, the old ones didn't. The only difference between the original and the new neon bar are the color of the bar, increased sugar content, and design change. The company's development team has been debating on what could be causing the hyperactivity. Developer A suggests that the type of food coloring used in the neon candy bar is causing the hyperactivity, and a new type of food coloring should be explored. This claim has basis or merit because there was a study done a few years earlier that showed a competitor's candy bar increasing hyperactivity when the same food coloring was used. Developer B doesn't believe that the food coloring is responsible. She suggests that increased sugar content of the neon candy bars is to blame for the hyperactivity of the children. While there is little scientific evidence linking sugar to hyperactivity, many parents of hyperactive children claim that sugar makes their children's behavior problems worse. Developer C believes it is the new ink on the packaging. The new design incorporates neon colors, and the ink used has harsher chemicals. So they want you to come up with a hypothesis, a guess as to what could be causing the hyperactivity in these kids. So you have 3 possible culprits. It's either the sugar content, the color of the package, or the dye used in the candy bar itself. So you look, come up with a quick hypothesis. So I said, based on the evidence presented, sugar is not the reason for the hyperactivity. I should have said is probably not, just because that has been shown to be true, that sugar is not increased hyperactivity. So anytime you have a hypothesis, you should always have an if-then statement. So if something, then something. So if it is not the sugar causing the hyperactivity, then it must either be the packaging chemicals or the food coloring, which has been shown in other studies to cause hyperactivity. So here's your if, then. Right here. So that's kind of what you want to do. It's pretty straightforward. They just want you to come up with a guess as to what's going on and then put it down. And just based off the evidence that they suggest in this, that's what your hypothesis should be. So as part of the experiment conducted by the candy company, a group of children was given a new candy bar with less sugar than the neon candy bars. The group of children experiences extreme hyperactivity. So that's where I got the sugar is probably not, because the kids ate less sugar and they were still super hyper. Using information from the package suggests a hypothesis in answer to this question. All right, so 17, herbivores, animals that only eat plants. Carnivores are animals that eat other animals and meat. Typical herbivore and carnivore teeth patterns are shown below. So here's a carnivore, you have a dog. Herbivore is a sheep. You look at their teeth, right? So incisors, canines, premolars, molars. So you look at this one, incisors, premolars, molars. So you're missing canines on the sheep. These are like the tearing teeth, basically. What is the most notable difference between the dog's teeth and the sheep's teeth? Aside from them being, the sheep's being pretty flat and the dog's being all pretty sharp, the dog has fewer teeth than the sheep does. Not true. The sheep has fewer teeth. The dog has molars and the sheep does not. Nope, they both have molars. The dog has incisors and the sheep does not. They both have incisors in the front here. The dog has canines and the sheep does not. There's your answer. Canines. The sheep doesn't have the canines for chewing. So that's your answer. So this one, the 5 largest asteroids. So here's 5 asteroids they give you. Average distance from the sun. Time to orbit the sun. So how far it is from the sun, and then how far it is from, or how long it takes to orbit. The Earth is considered one. So this is 2.77 times Earth, 2.77 times Earth, 2.36 times Earth, 3.13 times Earth, like how far it is, 3.6 how farther from Earth. Which of the following statements is supported by the information on the chart? Pallas is further away from the sun than Hygeia is, so Hygeia, Ceres, or Pallas. Nope, that's an incorrect statement. Of the 5 largest asteroids, Vesta has the longest orbital period. You look at that, Vesta does not. It has the shortest. The 5 large asteroids are all further from the sun than the Earth is. So if the Earth is 1, and these are all 2 times, then your answer is that. One of the 5 largest asteroids, only Interamnia, takes more than 5 years to orbit the sun. Incorrect, because Hygeia and Interamnia are both more than 5 years. So process of elimination tells you this one. But you can also look at the chart here. If Earth is 1, then these are all more than 1. So they are all farther from the sun than the Earth is. So the American lobster, Homarus americanus, is typically bluish green to brown in color. However, a rare genetic mutation estimated to occur in 1 in 2 million lobsters can result in a bright blue colored shell. In 2011, 220 million pounds of lobsters, typically weighing 1 to 9 pounds each, were caught. 2 blue lobsters were reported in that time. So, in 2011, the experimental probability of catching a blue lobster was greater than, approximately the same as, or less than the estimated probability of a lobster having the blue mutation. So we see that 1 in 2 million lobsters have the blue mutation. So there's odds are you're going to at least catch 1 in there, right? So they have 220 million pounds of lobster. Whoops. So if you want to, you can go ahead and divide it by 9. And assuming each one weighs 9 pounds of this 220 million, and you're going to get 2.5. So they only caught 2 lobsters. They should have caught 2.5 or more. So your answer is less than, because the probability was less than the estimate. So it was estimated that there'd be 1 in 2 million. So there'd be 2.5 blue lobsters, or I mean, you could round it up and say 3 blue lobsters. But anyways, it was less. So in 220 million pounds, they should have had several of the blue lobsters. But they only found 2, so the experimental probability was less than the estimate. So your answer is less than. Structure of a volcano. So you have the lava plug, which is like the seal at the top. The pressure from the magma, so the heat creating tons of pressure. And then lava cones and ash layers, so all the stuff that's already blown out. Based on the diagram, what causes a volcano to erupt? Pressure builds up inside the magma chamber and vent. So you look here, so you have this heat, and it's hot magma collects in the magma chamber underground. So this is super hot. Here's the pressure that's forming in the main vent and branch pipes right before the lava plug. So all this heat is rising, and all this hot magma is up here pushing against this, creating a ton of pressure that's going to blow the top. So magma flows down towards the underground chamber. The magma doesn't, it flows upwards, and it's causing severe pressure. The lava plug at the top of the vent wears away. No, this is a pretty set area right here. It's pretty hard. It's usually cooled lava or rock. The lava plug at the top of the main vent collapses inward. That's not, I mean, common sense shows you that if everything's pushing up, that's probably not going to go down. That wouldn't make any sense. So your answer is going to be that the pressure builds up because you just have intense pressure. Intense pressure causes it to explode outward, right? In chemical reactions, the atoms of the reactants are rearranged to form products with different chemical and physical properties. A catalyst is a substance that speeds the rate at which a chemical reaction takes place. However, the catalyst is unchanged at the end of the reaction. So, if you start with something and it causes a reaction, whatever you started with should be unchanged at the end. It should be exactly the same as it was. The catalyst itself is unchanged. In which of the following reactions is the catalyst at work? When acid is neutralized, as when hydrochloric acid adds to sodium, hydroxide yielding sodium chloride and water. So you're neutralizing the acid, and when you neutralize acid, it yields a whole new thing. It yields a whole new chemical. So that you're not keeping the catalyst the same. When food is digested and when an enzyme in saliva called ptyalin breaks down starch into sugars without itself changing. So right here it says the catalyst itself is unchanged. The starch and sugars, when the food is digested, the enzyme is breaks this stuff down, but the enzyme doesn't actually change. So you can just look without itself changing. Itself is unchanged. So there's your answer. If you see an answer that looks correct to you, go ahead and mark it. You can always flag them and come back. But usually if you see something like that and your gut is giving you that answer, go with that. Because usually, like I said, the question is usually restated in the answer somewhere, or there's some key words to look for. And that's a perfect example of it. So for 5 years, researchers at the University of Wisconsin Medical School ran an experiment in which they evaluated the hearing of 3,753 people between the ages of 48 and 92. Of the group, 46% were non-smokers, 30% were former smokers, and 14% still smoked. Scientists found that the smokers were nearly 1.7 times as likely as non-smokers to suffer hearing loss. The study suggests that age-related hearing loss might be preventable. Which of the following statements is most likely to have been the researchers' hypothesis? Smoking has been shown to harm in health in many different ways. People can reduce their chances of developing age-related hearing loss by not smoking. The University of Wisconsin study group consisted of 3,753 people between the ages of 48 and 29. Smokers were nearly 1 times as likely as non-smokers to suffer hearing loss. So this one is going to be your conclusion to their study, so not correct. This one isn't talking about the smoking. The smoking is the study here, like smoking and hearing loss. So smoking has been shown to harm health in many different ways. That's common sense, and that's not specific enough to what the study's asking. The study's specifically talking about hearing loss. So people can reduce their chances of developing age-related hearing loss by not smoking. So that's going to be your answer right there.